All right, so today we're talking about asteroid impacts. We're going to talk about this today and tomorrow. Well, actually, we'll talk about today. We'll talk about something a little bit related tomorrow. So, in our little game, we had 5 people with 5 throws each, so we had 25 throws, and we had 0 hits. So, according to this, we have a 0% chance of hitting the target. Do you think that with a little more practice, we would have gotten the marbles into the ring? Or do you think it's impossible? It's impossible? Good.
It's possible. It's rare.
Rare, yeah? Because I just came up with that game off the top of my head. It's not like I tried to rig you guys or anything. The bumpy floor didn't help, that's for sure. Okay. So let's talk about some numbers. Let's talk about how many asteroids there are and how many asteroids are close to the Earth. So here's another graph for you guys. So this is from the NASA Center for Near-Earth Object Studies. And this graph shows how many asteroids they found passing close to the Earth since 1990. Now, let me make this clear. This is discovered asteroids. So these are only the asteroids that have been discovered. They have not discovered all asteroids, but these are the ones that have been discovered that have been close to the Earth. So in the year 2021, they discovered 16,000 asteroids, and added all that up for the asteroids discovered since 1990. We've discovered 26,000 asteroids in the last, 20 years, 30 years that passed close to the Earth. So if we had 26,000 tries, do you think wouldn't we land at least one marble inside the ring? 26,000 tries? Yeah, probably at least one, hopefully more than one. Can you guys guess how many asteroids it would take to cause a lot of damage on the Earth? Yeah, just one, right? So when it comes to asteroids, it's really not about if asteroids impact the Earth. It's not really about, it's really a matter of when, where, and how dangerous these asteroids will be. So here's a question for you guys. What is most of the Earth covered in? Yeah, most of it's water, right? So if an asteroid were to hit the Earth, chances are it would hit the ocean, but we can't be guaranteed of that. We're talking about asteroids that haven't even been discovered yet, so we really don't know where they're going to hit until they hit. So let's talk about, over the next couple days, we're gonna answer the question about when and where, but today right now we're gonna focus on how dangerous these asteroids could be. So in the reading I gave you guys, there's this equation. If you've ever had me for physical science or physics class, you might remember this equation. Kinetic energy equals 1/2 the mass times velocity squared. So I know we haven't done math in this class, we haven't messed with equations, so let's talk about this equation. So kinetic energy is the energy of motion. When asteroids and the Earth goes around the solar system, everything's moving. So everything has this thing called kinetic energy. It's the energy of motion. When an asteroid collides with the Earth, well, if the asteroid was moving and then it hits the Earth, where does all that asteroid energy go?
To the sky.
Into the sky or into the Earth. It has to go into the sky or the Earth. So that energy has to be transferred. So the energy is transferred according to this equation. We have 1/2, which is just 1/2. Then you have mass. Does anybody remember what mass is? Or does anybody know what mass is? Not size, it's kind of related to it. Come on, where's my physical system students at? It's sort of like the weight. So mass is like how much stuff you have, how much matter. What about velocity? Do you guys know what velocity is? Yeah, velocity is like speed. Now you guys notice on this equation, it says 1/2 times mass times velocity squared. So if you're trying to determine how much kinetic energy something has, does the mass or the velocity impact the energy more? So between these two terms, mass and velocity, which one of those impact how much energy has more, or which one has more weight? Did somebody say velocity? So notice that velocity. Notice that velocity says squared. What is that? What does squared mean when you square something? Do you guys know? It's not double. Squared means you multiply it times itself. So another way to say this equation is 1/2 times mass times velocity times velocity. So if you increase the mass, then yeah, that increases kinetic energy. But increase the velocity, that increases the kinetic energy by a whole lot. So both those terms are important, but velocity is the speed of something really matters a whole lot more. So let's look at an example asteroid. So let's just say that we had an asteroid that was 10 million kilograms and a velocity, of 20 kilometers per second, or that's the same thing as saying 20,000 meters per second. So again, that's heavy and that's fast, because lots of asteroids are heavy and fast. The kinetic energy would be 4.5 times 10 to the 15 joules. That's a 4 with 15 zeros after it, or 4 quadrillion joules. That's a lot of energy. And I know we don't really use joules that much, but you'll have to trust me that that's a ton of energy. And the scary thing is that this is not just an example, this actually happened. In February 2013, the Chelyabinsk meteor exploded over Chelyabinsk, Russia, had the force of about 20 to 30 World War II nuclear bombs, and about only 1,500 people were injured. Now notice the key word here is over. It exploded over Chelyabinsk, Russia. It did not actually explode on the ground, it exploded in the air. So what happens is that when asteroids enter the Earth's atmosphere, sometimes they explode in the air, sometimes they hit the ground. It does, we can't really tell what's going to happen until it happens. But this actually happened. So if it exploded on the ground, a lot more than 1,500 people would have gotten injured. What happened was, when this thing exploded, it let off a really bright light. It was brighter than the sun for a little bit. And so all these people are rushing to their windows and like, wow, look at this meteor come through the sky. And as they're looking at this big bright light in the sky, what they don't realize is that there's a shock wave approaching, and that shock wave blew out any window that people were standing next to. So if you're right up to a window, the window shatters right next to you. If the light doesn't blind you, that glass is going to get in your eyes. And so 1,500 people went to the hospital because they had some sort of glass-related injury or some sort of blindness-related injury. And that wasn't that long ago. That was February 2013. Can anybody guess how NASA found out about this asteroid? Yeah, they actually found out through Twitter. So this was an unwarned meteor. Nobody knew it was coming until people posted about it on Twitter. So tomorrow we're going to talk about asteroid detection, how asteroids are actually detected. Here's another example of an asteroid impact. Now this one happened a long time ago. This was before, like thousands of years ago. They don't know if there's an exact date, but this is in Arizona. So this is the asteroid crater that was left. So this is 1,200 meters across, and remember this room is about 10 meters across. So imagine 120 classrooms across by 170 meters deep. So that's like that should say 17 classrooms. The asteroid itself is estimated to be about 50 meters across, so that's 5 of these classrooms. So if you were at this spot thousands of years ago, well, you'd be dead now. But if you were there, where the crater is now before the asteroid hit, do you think you would be alive to tell what happened? No. So anything that was there was completely obliterated or burned when the asteroid impacted. The cool thing about this asteroid impact, about this crater, is that it's in the middle of a desert. There's lots of examples of craters around the world, but a lot of these craters are in jungles or under the ocean. But in the desert, there's not much erosion going on. There's not many plants to wipe out the evidence. So this crater is clearly seen. But there are examples of these kinds of craters all around the world. Did anybody have any questions? Do I need to stop the questions yet? Okay. So again, it's not a matter of if, it's not a matter of when, sorry, it's not a matter of if an asteroid will impact, it's a matter of when, where, and how dangerous. So that hopefully that'll help you with your first quiz, or not first quiz, that first assignment you guys had. Let me give you guys one more. This is already on Google Classroom 2. So this is a Wikipedia page, and what this tells you is that this is a list of asteroids that have impacted the Earth. Oh, I'm sorry. This is a list of asteroids that have come close to hitting the Earth. You guys read about this, but on the next few pages, there's color coding. And the color coding basically tells you how much warning we had before these asteroids were discovered. So I'll let you guys read about that.